This is Module 12, third video. We're going to go through an example where we see how to do a hypothesis test for correlation. Now recall in the last video we discussed how we're going to take our sample points, our XY values, we're going to randomly shuffle them, and we're going to see that the correlation coefficients, the distribution of sample correlation coefficients, will be centered around our hypothesized value of rho. Remember, our null hypothesis is always going to be that there is no correlation in the population. So we're hypothesizing that rho equals 0. Our alternative hypothesis will be two-sided. Rho is not 0. So our sample correlation coefficients are going to be centered around 0. That makes sense because if we're randomly assigning the X and Y values together, we're going to be seeing a bunch of sample correlation coefficients that come from data sets that are just random messes of points. So they are going to be correlation coefficients very close to 0 because they're just going to be random points all over the place. So then we will find our actual sample correlation coefficient R on this distribution of sample statistics, and we will see if our R is way up here in the tail, then it will give us a lot of evidence in support of the alternative hypothesis. If our sample correlation coefficient R is in this expected area, around rho equals 0, then it would give a lot of support for the null hypothesis, that there is no correlation. All right, so let's look at an example. All right, the example. Is there a relationship between the change in mood and the intensity of exercise? 32 female college students were sampled. They measured their mood before and after exercise, reporting whether or not there was a change in mood and also recording their exercise intensity. So if there is no relationship between mood and exercise intensity, then what would the correlation coefficient be? So if there's no relationship, there would be no association. So that would mean the correlation coefficient would be 0. Notice here we are talking about the population correlation coefficient, rho. All right, so our null hypothesis and alternative hypothesis. So our null hypothesis is always that there is no correlation in the population. There's no correlation between exercise intensity and mood. And remember, the alternative hypothesis is going to always be two-sided. So we would say that there is correlation between exercise intensity and mood. Part C. It asks to open the correlation regression applet and paste the data in. So at the bottom of this, I do have the data. I'm just going to copy it. Remember, it's the least squares regression applet that we use. I clear the old data, put my cursor in and hit paste, and I paste in my exercise and mood data and hit use data. Along the horizontal axis, it has the exercise intensity. Along the vertical axis, it has the change in mood. So there's the points. If I want to see the correlation coefficient, I can click right here. Remember, this is a sample, so that I'm going to see a sample correlation coefficient. There it is, R equals 0.187. That makes sense because this data does not appear to have much correlation. It does not seem to resemble a line very much, so my correlation coefficient is pretty close to 0. So I wrote R equals 0.187 is the statistic. This is the sample correlation coefficient. It tells me that there doesn't appear to be much correlation between exercise intensity and mood, since the R is close to 0. All right, so now we're going to actually test our hypothesis. Remember, our hypothesis was that the population has no correlation. There's no correlation in the entire population. So if I go back to the applet here, we're going to click Show Shuffle Options. I'm going to do just one shuffle. What it's going to do is it's going to take these X's and Y values and it's going to randomly assign each X in the list to one of these Y's. It's going to just randomly shuffle them. You want to select correlation coefficient and you shuffle the Y values. All right, it did. It took those X's and randomly assigned them to the Y's. And this is the data points that we get from the random shuffle. And it tells me the correlation coefficient for that random shuffle. You see down here, it tells me those points above have a correlation coefficient of 0.027. And so there it is plotted, 0.027. If I shuffle again, it reshuffles and assigns the X's to the Y's. There's the data points, the scatter plot. And this time I got a correlation coefficient of negative 0.366. There it is, plotted. And if you continue to hit that, shuffle, 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 you see each time it looks like just a random mess of dots. And the correlation coefficients we get are all pretty close to 0, which makes sense because if you're just randomly assigning X's and Y's, you would expect to get random dots all over the place and a correlation coefficient pretty close to 0. And that's what we're seeing. And you can see over on the right side, it's building that distribution of sample statistics that we expect to get when you are just randomly shuffling and assigning the X's to the Y's. I'm just going to up that to like 100. All right, there it is. Could even do it again. There's a whole bunch of them. And you see, as we expected, we're getting a distribution of expected sample statistics, expected values of sample correlation coefficients are if we're just randomly assigning. Notice it's centered around 0. And it seems to expand out to like, I don't know, 0.6 and negative 0.6, but that didn't happen very often. I would say it seems pretty normal to get things like R equals 0.3 and R equals negative 0.3. So that span of correlation coefficients for your sample seems to be expected and normal. Part D, E, and F are just kind of explaining and step-by-stepping your way through using that simulator. I'm actually going to just jump down here to part H, where we can take the distribution that we created in the simulator and answer some questions. So here's that distribution of sample statistics. It's the distribution of sample R statistics that we got when we randomly shuffled. And it says, just eyeballing it, describe how our sample statistic compares to the statistics produced. So our sample statistic was R equals 0.187. Remember, that's the actual sample statistic we observed. So R equals 0.187 is about right here on that distribution of sample statistics. It is totally normal, usual, and expected sort of sample statistic to get if we're just randomly shuffling and creating these sample statistics. So what does that tell me? It tells me that the null hypothesis is plausible. In context, remember, the null hypothesis was that there's no correlation in the entire population. In context, that's saying that there was no correlation between exercise intensity and mood. Okay, we can actually now get a p-value using the simulator. We expect to see a big p-value. Remember, if you say the null is plausible, that means you're going to have a big p-value. Back in the simulator, to get a p-value, down underneath your distribution, you see the count shuffles. We have a two-sided test, so I'm going to select beyond. I put my sample statistic here, 0.187, and it's going to count samples that are like my sample statistic and more extreme. So it's going to locate 0.187, which is about right here, and it's going to count samples like that and higher. It's going to go to the opposite side of the center and identify that spot and count samples like that and lower. There we go. So it turns out 31.96% of the samples are like mine and more extreme. The p-value is 0.3196. I'm going to say it's about 0.32. asked us to interpret that p-value in part J. So that would mean if there is no association between mood and exercise intensity, then the probability of getting a sample like ours or more extreme is 32%. That's a big p-value, so that means the null hypothesis is plausible. Just as we said above, that means it's plausible that there is no association between mood and exercise intensity.